Hello and welcome back to another JPizza tutorial. It's been a while, and today I'm going to be covering complicated variables, or advanced variables, whatever you want to call them. Up here it says complex variables. It doesn't really matter. Basically, advanced variable manipulation. The first thing I'm going to show you is called a callback variable. Now, a callback variable is similar to a macro in other languages, where it is not evaluated when it is assigned, but rather it is reevaluated every single time it is called. For example, let's say callback variable y is just going to be equal to x squared. Now, even though x is not defined yet, it's okay. We're going to want to define x, but we don't even have to define it yet. So what I'm going to do next is say x is equal to 4. Let's try printing y. And then I'm just going to set it to 8, and then we're going to print y again. Let's see what happens. So it's reevaluated every time. We're going to call y is x squared. So when x is 4, x squared is 16. When x is 8, x squared is 64. Now this can be applied to things like our tic-tac-toe game, where if you remember, we had this playing function, but instead we can change this to call playing, remove this, and voila, now we can just remove this and this, and it works just the same. This is evaluated every single time it's referenced, so we don't have to worry about the whole lambda goofy stuff. Now let's look at statically typed variables. Similar to other languages, JPizza also has statically typed variables, which basically mean once it's given a type, anything assigned to it cannot have a different type. So for example, up here, our x, we can use this hash operator and give it a type of num. Now there's going to be an error because it's going to automatically assign null to it, and null can't be assigned. So let's just assign -1 to it for now. Yeah, there was an error because null is not our number. And as you'll see here, if I try and do equal to like a string, we're going to get an error. Got type string, expected type num. If we want to, though, we can redefine x and change its type like that. And no error. Now, if you want to make it accept any type, but you still want to add these little annotation things, you can just do any, which is the default. This can just help increase code readability. Now you see, I can assign it to anything, and it won't get mad. Now, whatever this is what the type function returns. So if we have a custom class, let's say we have a class cool object. Let's say it has an attribute, not x, we already did. Let's have attribute z. So it's going to take in z when it's created, assign z to z. And then I'm going to override the type method so that it returns cool object dash z. I might have to put that in parentheses. Oh, semicolon. That's what. Expected. It's right there. All right. I guess I'll just do that then. Oh, it's because I'm defining it like that. All right. There we go. Now that we have that, Return. Okay, anyways, now that we have this, now that we have our custom type, let's try making a new one. Let's do var c cool object. We don't want to use dashes. Let's do cool object 3. And let's create a new instance of cool object 2. Now this isn't going to work because it expects, whoa, alright, but it's nice. It's not going to work because it gets type cool object 2 and expected cool object 3. We just change this to 3. This example is not going to work because of the 3.0, but if we did something like cool object high and entered in Jai, I don't know, typo, it's not going to work. Change this to that. So yeah, whatever's outputted by the type function is the type that you're going to look for. So if you're working with something like arrays from the utils library, that has a custom type that you're going to want to factor in. So like number array and stuff like that. So those are things you're going to want to remember. But yeah, this has been static types and callback variables. And I'll see you guys in the next one, which will be uploaded shortly.